Now, Audacity. I'm recording in Audacity. Are you also recording in Audacity?
I am, and I'm catching a little bit of you, so I'm going to turn the mic down.
There you go. That's the thing. That's the business, like they said.
Eeny, meeny, miny, mo, testing on the radio. There you go.
All right, so let's do the routine here. Eeny, meeny, miny, mo.
Testing on the radio.
Eeny, meeny, miny, mo.
Testing on the radio.
Eeny, meeny, miny, mo.
Testing on the radio.
All right, Pete Giuliano. It is Tuesday, November 17th, 2021. That makes this SolderSmoke. What's the number, Pete?
234. Crank it in, Robert. Crank it in, Ralph.
Robert and Ralph,
234.
crank it in, fellas. Crank it in, man. 234. Hold on, I got to get you up on the screen here, Pete. I want to be able to see you because we're now we're on video too. Hold on a second here. I got all kinds of weird things. There you go. I can see you now. I can see myself. We're recording. We're rocking and rolling here. Pete, many things to talk about. I know your time is limited, even though it's 05:30 out there on the left coast. But thank you very much for getting up early in the morning for us. Hey, listen, we got some interesting messages. We got a nice one about the origins of SolderSmoke, the roots of SolderSmoke, the roots of the podcast. And it was from a fellow named Steve Smith out in California. And he said he liked the podcast a lot and said that you and I are the click and clack, the Tappet brothers of ham radio. And I took that as a real honor, but it reminded me, yes, indeed, that was one of our early influences. And people from time to time asked about this. I think I would have to say that in my case, one of the early influences was Gene Shepard. People have told me that I'm trying to become sort of the reincarnation of Shep. I think that's going a little bit too far, but he was definitely an early influence. We also mentioned Click and Clack, the Tappet brothers, definitely. I really like their style. They're kind of back and forth. They're kind of having fun with car stuff, car talk. This is, I guess, shortwave or single sideband radio stuff.
Yeah.
And then I guess the other influence was shortwave stations, doing shortwave listening as a kid. We'll talk about that when we get down to the mailbag because we have some things to say about that. But just about this fellow, Steve Smith. When I saw Steve Smith, he didn't give his call sign. And I, for a moment, thought it was the famous Steve Snort Rosin Smith. You know, this fellow who wrote was from California, too. I think Southern California.
San Diego.
I all started thinking, man, maybe this is Steve Snort Rosin Smith just not giving his call sign. So I asked him, I said, are you the famous Snort Rosin Smith? And he replied, he said, no, I'm sorry to report that I'm only Steve, the aching sinus Smith, WA6SOC, not WB6TNL. But we hope that Snort Rosin will chime in eventually here.
You know, he lives in Oxnard, Snort Rosin.
Yeah.
Oxnard is just over the hill from where I'm at, maybe 3 miles.
Oh man, you guys, this be good, be good. He was a real influence. You know, he was one of the first guys who pointed out that my thinking about an 80-20 or 75-20 I got somebody sent me a 9 megahertz filter. And I was like, woohoo, I could make an SSB rig, LSB on 75, USB on 20. I won't even have to switch the carrier oscillator. Wrong. Steve Smith came back and said, wrong. One of the early guys, one of the first ones. Anyway, we'd be glad to hear him. And thanks very much to Aching Sinus Smith for his kind and very insightful remark about the origins of the podcast. Pete, you got many things on your bench. You go first, man. Tell us what's going on.
Yeah, well, two things first. First, I want to recognize your exalted status in the member profile in QST, and so I have formalized my appearance today by wearing my black tie. Actually, this is called a Seattle tuxedo. It's a
Seattle tuxedo, like dress blues and tennis shoes, just like in the old days.
Yeah.
You know, but Steve, Pete was the one who asked me about whether he would be required to wear a bow tie during future podcasts. And I just responded, I said, well, yes, since now I am one of the Illuminati,
there you go.
Formal attire will be required. I mentioned later on that Chuck, WA7ZZE, he also saw the QST profile and asked me if he had to call me sir from now on.
There you go.
I just said, no, Well, I think we should keep it informal.
Yes. Okay.
Anyway,
Hey,
okay, but I like the tie, Pete. It's nice.
Yeah, I wanted to comment about Gene Shepard. Gene Shepard. When I did the GQRP second virtual convention on valves and CW, I note in there special deference to Gene Shepard. His favorite transmitter was the Tri-Tet. Did you know that?
The Tri-Tet. Is
The
this like a
Tri-Tet
69? No,
pardon?
this is not a 69 tube.
No. The Tri-Tet oscillator is the combination triode tetrode.
Right.
That's
Okay.
the James Lamb 1933.
Yeah.
That was his favorite transmitter. So it's in the presentation. When that becomes public, you'll see that mentioned. Special deference to Gene Shepard.
That's right. The Shep, man, Excelsior. That's all I got to say.
There you go.
And his story about Heising modulation and his problems with Heising modulation.
And the girlfriend.
He was so distracted because he couldn't get his Heising modulator to work that he wasn't paying any attention to the girl on the date. And then finally she asked him what's wrong, and he said, I can't get my Heising modulator to work properly. And she looked at him and she said, there's something wrong with you. I think your mother should take you to a doctor.
Yeah, there you go.
We've all been there. That's it. I mean, listen, if you can't get your Heising modulator to operate, how can you think about anything else? I mean, geez.
Hey, I do want to make a plug for the Shameless Commerce Division early, Bill, because it's about a month is Christmas.
Oh my God, yes, but it's a supply train. Kids mixed everything up, so no Santa this year, Pete.
Well, if you're going to get something, you better get it early.
That's right. That's it. There you go. We don't care here in the Shameless Commerce Division as long as we get the moolah.
Yeah,
So we'll order your stuff from Bezos early.
Yeah, there you go.
And use the link on the SolderSmoke blog.
Yeah,
it is unaffected by supply chain problems. There you go.
Yes. Yeah, he isn't unaffected. I haven't found anything that I've looked at there that's not available.
Well, I know, but I found one yesterday. I was looking for a piece of pine board.
Ooh.
Because now all my rigs are built on pine board, in deference to Frank Jones and others. But I was looking for a piece of pine board, and they did not have the dimensions that I wanted. So that I had to turn to Home Depot. Home Depot had the dimensions I wanted, but then by the time I got through with that, I figured that I probably had one out in the junk bin of wood parts, and I went outside and I have it. So I have a pine board ready to go. But you're right. Most of the time, Bezos has whatever you're looking for.
Yeah, good stuff. Okay, what's on my bench? I think I'd first like to start with the PSSST, the psst, 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 the newest transceiver from N6QW. And this is a 7 transistor solid state single sideband transceiver for 20 meters. 7 transistors. And there was a design premise when I started this project, and the design premise was no BIDX circuits, no TIA circuits, no EMFRD circuits, no Facebook groups. And the whole idea was, what can you do if you're not constrained by using elements of those prior rigs or prior approaches? And I came up with something. And it's got some steerable modules, and using a bunch of relays, communications relays that can be bought for 45 cents a piece. You can steer modules in there so that they have one path on receive, one path on transmit. This project is extensively documented on my website, and no one gives a crap.
Oh, yes, we do. Yes, we do. I have been following it, and when the world hears about it through the SolderSmoke podcast, they are going to care about this project.
Well, the thing is, it's very simple to build. It's minimalist. I mean, there's very few components in there, and it uses 5 2N22 22A transistors, 1 2N2219, and 1 IRF 510. Stuff that you can buy for less than $5. Matter of fact, the heat sinks for the 2N22 22As cost more than the transistors. But we have,
that's the price point that we're aiming at, because when you talk about radios and stuff, it's better to say price point than price.
Yes. Yes.
Price point sounds more impressive.
Yes. Yes.
Yes, that $5 price point is about
Yeah.
where we aim most of our radio projects.
And I have been having a blast with this rig. Have been working a lot of DX with it. Now I do have a little afterburner on it, about 75 watts, and just the Delta loop. I've been working a lot of DX with it, a lot of stateside stations. Have been working some QRP, and I paid a lot of attention to the microphone amplifier. And the microphone amplifier, there are curves in there from LT Spice. I really paid attention to the low frequencies so the signal has presence. And one of the most frequent comments I get is, God, it really sounds great. So it pays to do the simulations and to address the low frequency. This amplifier is good from 20 hertz to 20 kilohertz. And the audio reports are all excellent. No, it sounds tinny, pinched. You don't hear that. And you don't hear, hey, it sounds good for a homebrew rig. It's
oh man, that's
statement is it really sounds good.
Because if they say it sounds good for a homebrew rig, Pete, I think you got to send somebody out to see them.
Yeah, right. Gonna make a visit. So anyway, the PSSST, and you can find that by going to the n6qw.com, and then you do the backslash or the / the PSSST in caps _20.html. That's the URL address for that.
Definitely check it out, because this is, I think, really, really interesting. I like the way you do the steering of the IF module. I've looked at it. It's really, really nice. The pictures are great. I like the two ADE ones at either end. Really nice. So, I mean, definitely do take a look.
There's even board layouts if you want to make PC boards. I mean,
that's it. You could build these things. You could build one.
Yeah, build one in your garage. But I am somewhat disappointed. I posted it on the GQRP group IO. I got one email. How come there's no CW?
Oh, oh well.
That's.
But I'm sure sometimes that mailing list, they take a little while to respond. I'm sure people are thinking about it, looking at it, and I mean,
not that I'm so much interested. I'm having fun with the project. That's the important thing, and I'm getting use out of it. And people are. I mean, I even talked to a guy yesterday, big time ham in Virginia, and this guy is pretty discerning, and he even said, man, that really sounds good. So when you get these guys that are really picky and are well known, and they say it sounds good, that's an important piece of information. Okay.
That is really good. And I mean, it's great that you documented it. I mean, because like we always say, with the podcast and with the blogs and everything else, you might not get somebody who grasps onto it now, but somebody 2, 3, 4 years from now might, suddenly start looking around for a project and come across yours. I mean, I'm going to talk in a little while about my first SSB transmitter, and I got that from a Sprat article by G3YCC, Frank. And I got it, and it was years after he wrote it, and then I got it and I built it, and that machine is sitting behind me there on the workbench. We'll talk about that in a minute.
Yeah.
But
the other project I was working on is I got the KWM1 working.
You took it off the shame shelf.
Off the shame shelf, yeah.
I really like that phrase, and I sent it to Steve Silverman, our official lexicographer.
Yes.
And I think it definitely should be included in the SolderSmoke lexicon, the shame shelf.
Yeah, well, that has several meanings. The shame shelf, it's a shame it doesn't work.
And I'm ashamed that I had to put it up there.
Yes. Yes, absolutely.
Even Doug DeMoore, I remember Doug DeMoore writing that he admitted, I don't know whether he admitted that there were projects that he couldn't get to work, but he definitely admitted that he built some stuff that he didn't understand. He didn't understand how it worked.
Mm-hmm.
I guess that's a variation of the shame shelf, but go ahead.
Well, the thing was, when I bought it, the advertising for it says it doesn't work on receive. You can't hear the crystal calibrator, and I said I can fix that. And so I did get it working, and then it stopped working, and then I found out why. There was a broken wire on the relay. That broken wire must have been broken before, and somehow when I was jiggling around, it touched the contact. And then I moved it again. But I mean, it was like finding a needle in a haystack, the broken one, because they were in a wire bundle that went to these multi-contacts. So when you just look at it, it looks like it's connected, but it wasn't.
It's just these are the kind of things that'll just drive you nuts.
Yeah.
I mean, I had this one time on the a variation of this on my point 0.1 kW linear amplifier. In the low pass filter that I built for it, I used these big old toroids because it was up to 100 watts, don't you know?
Oh yeah.
And and it was kind of going in and out, in and out. When I'd be working a sideband contact, and all of a sudden, boom, power out would go to zero. I thought the problem was a connection in the D104 microphone. I tore the D104 apart, all the connectors. I soldered them where there was just a connector. And then only later did I realize that one of the copper wires that I had on the coil had stressed and de-stressed, I guess, to the point where the wire broke inside the insulation. Inside the insulation.
Oh yeah.
So if you looked at it, it looked
Good.
perfectly normal.
Yeah.
But only when you took the multimeter and checked, wow,
Open.
supposed to be
Yeah.
closed.
Yeah, yeah. Hey, I want to introduce a concept here. Okay?
Tell us.
Concept.
Listen, tribal wisdom coming. Tribal wisdom.
Well, actually, it's more. I've been noodling the idea of an equipment exchange website or an parts exchange. Like I'm looking for something. Do you know if anybody has done that where they post a list of I am looking for this?
Well, you know what? It's interesting you raise this because for a while, guys were passing around by mail a box with like discarded electronic parts. And the deal was, I guess it's like these little libraries that you see all through suburban neighborhoods. The idea is that when you get the box, you look through it. If you see stuff that you like or need, you take it out. Then you replace it with stuff that you, from your own collection, have that you don't really like or need, but somebody else might have. And then you send it to another random person, right? Or maybe people on a list or whatever. But the thing keeps circulating and people are constantly getting kind of a chance to look through parts. But I like your idea. Your idea is a variation of that.
Yeah. Well, I mean, do you know if there is such a thing?
I don't know. I haven't heard of one.
I mean, it would be nice if you went to a website and say, I'm looking for this. Or I have this available. Parts exchange.
Well, one venue that I'll mention, and I'm not going to mention the one that begins with F that you don't like.
Yeah,
No, I'm not. I know that would just blow some fuses. No, but I discovered something this week on the QRZ.com page. Where we always check some guy's call sign.
Yeah.
That thing has grown quite a bit, and there's a section in there called forums or fora. Mm-hmm. And if you click on it, there's like dozens of different forums on there, all kinds of different topics. And maybe the kind of parts exchange idea would fit in with one of them. I don't know. Or maybe you could create a new forum or have QRZ.com create another one. A lot of people look at those things. So it's pretty wide visibility. You might want to take a look, think about doing it there. That'd be interesting.
Yeah.
If anybody else, any of you e-gurus out there, send us ideas how best to do what Pete's talking about, because I do think it would be a really interesting project.
Yeah, I mean, I'm looking for a knob for a radio, because I'd like to restore it so that it's got the knob. So the knob may cost a couple of bucks. Where do you find one? I mean, you look on eBay, but someone's got a drawer full of knobs. Yeah, I got one of those. Send me $2 and to cover the postage, and it's yours.
Yeah, I think it's great. I mean, there's so many parts that I do that yet I know that even if I went out onto eBay, that nobody would have I was looking L8 on the double crystal lattice filter in a Swan 240.
There you go.
And now, Pete, I know you may have 3 of them.
Yeah, yeah.
Because you got 3 of everything. And there are other guys out there who have similar collections. So that'd be an interesting thing. Yeah, that'd be interesting, especially in the boat anchor world, the world of old gear, the world of KWM1s.
Yeah. Someone's
Anyway,
got a part.
What's going on? A lot of people are still building your DCRX, your DC receiver.
Yeah. Well, I was just going to cover that. We're now up to 90.
Yeah, you see, so when you say people don't pay any attention, if you got 90 people out in the world building your receiver, this is phenomenal.
Well, I'm not sure 90 people are building it. 90 requests for the code.
I mean, when you look at some of those projects that were in QSD back when hams were hams and knew which end of the soldering iron to grab and all that, I don't think any of them had 90 people building them. So,
Well, maybe because at the time that the stuff was being built, you couldn't buy it.
yeah,
If you wanted it, you
yeah.
had to build it.
I
So
think 90 is still pretty impressive.
but some of the requests are a little, they're bothersome, and you don't want to throw a wet blanket on it. But a guy says, "I'm new to home brewing. I've never built it. Where's the circuit board for this project?"
Yeah,
And that was a request today.
You get that a lot, you know. No, it's not a kit. No, it's different.
Yeah,
And
yeah,
so
yeah.
also sometimes, I mean, I get the same kind of inquiries sometimes, and I just kind of try to gently say, hey, look, you know, building a kit is different, and this is not building a kit. So you'll actually find this more rewarding. It's more difficult, but it's not just stuffing a PC board. You know, you could stuff a
Yeah,
PC board and not know anything about electronics, just stuff the parts in, you know, put
yeah,
R1 in R1 slot, you know.
yeah. You just look at the color pictures and match the colors.
No, and a lot of guys have written and said, yeah, you know, I built 3, 4 kits and didn't learn a darn thing.
Yeah,
And now I want to move into home brewing. And so, yeah, I mean, I think it's worth it to make the switch.
yeah, cool. So anyway, there's still some interest in that project, but I think that's kind of cool. And there's some interest too in CNC milling. And keep an eye on the CNC milling machine prices. I mean, they're down around $300. I mean, a year ago these things were like $600-700. I mean, around Christmas time, and there's nothing nicer than you want a second one, punch the start button, you're there. There you go, Bill.
Oh, man, there you go.
You gotta
Okay,
join the
listen,
club here.
contact Jeff Bezos. He could set you up. I'm sure he's got, you know,
He
many
does. So
CNC mills.
think smart. Yeah.
There you go.
$350. There you go.
Hey, Pete, you put up an article on your blog that I really liked, How to Make Things Work.
Yeah.
That was really good. I mean, there was a lot of good tribal knowledge and insight in there on I'm facing a problem that a lot of new home brewers get, and that is they build something, then they say it doesn't work, and they just look at it, and then they get mad at it. Then they get mad at the guy who published the schematic, like you,
Yeah.
and say it didn't work.
It sucks. No, it sucks.
But anyway, I think I put a picture up when I forwarded on my blog the article that you wrote. I found this picture of some guy who had tried to build an 80-meter double sideband.
Oh yeah.
Just, I mean, it was like, I don't want to make fun of anybody, but it was like the epitome of doing what I did when I was 14 years old. That is, you see the schematic, all you see is a bunch of parts and wires in the schematic. You can't even really see the distinct stages. So what you do is you just start slapping parts almost willy-nilly onto a board, trying your best to connect the one to the other where it's supposed to connect. And of course, when you're finished with the whole thing, it doesn't work.
Yeah.
Because the way you should have done it is the way you talk about in your article, and that is stage by stage. Build the AF amplifier first. Does the AF amplifier work? Okay, great. Move back to the mixer. Does the mixer mix? Does the VFO oscillate? Boom, boom. And when you do that in that way, in a methodical way, at the end, it should work or be real close. Or if it doesn't work, you know which stage is likely to be causing the problem.
Well, you know, I wanted to go over that point just a little bit. In the PSSST write-up, I talk about the sequencing of the build.
Mm-hmm.
And I said, if you build the digital VFO first, it then becomes a piece of test equipment because you can move that signal around. If you, instead of having the dial read 14 megahertz, read 5 megahertz, the output is at 14 megahertz instead of 23. And I said, if you built the low pass filter and connected the ADE1 and cranked the display so it reads 5 megahertz, you now have a 20-meter direct conversion receiver.
Mm-hmm.
So you can check you can peak the bandpass filter. You can make sure the ADE1 works, and the digital VFO now gives you a 20-meter direct conversion receiver. And if you have the audio amplifier, you're all set to go. And then if you build the microphone amplifier next, and you run that through the ADE1 and using the 9 megahertz BFO, you now have a double sideband signal. So there you are, building only two of the circuits, the bandpass filter and the microphone amplifier. You can test about 50% of the transceiver and know that you got a double sideband signal and a direct conversion receiver.
And you're learning so much along the way. You've just learned how to build a direct conversion receiver and a DSP transmitter.
Yeah.
And then you carry on from there, and then you end up with the SSB transceiver.
Yeah, those parts all work, and then you have the IF module, and you got a working receiver. So
this is reminiscent of some of the great stuff that Hans did in a different way with his QCX transceiver, where the transceiver contained the test gear that you needed.
Tune the bandpass filter,
Oh man, I mean, he was doing it at much more complex levels. You're at the simple end of the spectrum there, but the same idea. And I really like that idea. That's a brilliant idea about starting out with a DC receiver, using it to tweak the bandpass filter, which is one of the hardest things for people to do.
I mean, I looked at that and I said, hey, this will work if you build it in the right sequence. And I mean, normally you'd say, why would you build the microphone amplifier? Because you're using the packaged ADE1s. Now one is direct conversion receiver, the other is the balance modulator. And you have the digital VFO has built in what you need to test those circuits.
Man, beautiful stuff.
Yeah.
Hey, more recently, and I'm a close watcher of your blog, Pete, so don't think nobody out there is looking. At least I'm looking, and others are looking too, I know. But you had that interesting piece about diode switching or relays. And I know this is another kind of a sore point, because I get it sometimes. I'm a big fan of the relays too, because they're so simple, and they're easy to put there. They're cheap. I use them a lot. And then you'll get guys say, hey, listen, why don't you use diode switching? Dean hit me with that question at one point, because I think they were using diode switching in one of the rigs that his group was working on. And I came back and I just said, I don't know, I just sort of prefer relays. And you said, yeah, relays too. I know this has come up again, and people have asked you about why not using diodes for diode switching.
Okay, there's a couple of problems with that: signal isolation and signal levels. If you run a couple of watts through a diode, probably not a good idea. Say, oh yeah, diode switch the low pass filter. Well, some of those 1N914 probably can't take that. So I mean, a relay, the right kind of contacts. So I mean, it all depends. Certain low-level signals using the diode steering works pretty well, and I only included that to show you how you could do it. So I think you're going to have to try it for a particular circuit element, and if it works, some diodes are pretty lossy, especially if you buy 1,000 diodes for $5.
Yeah,
they're probably rejects. But I specify a specific diode, a 1N3070, 3070, and I didn't think that up. I had been in contact with Watkins Johnson when I built the Mimic transceiver, the transceiver that uses the 3 pairs of mimics. And they told me this 1N3070 has good RF properties out through the gigahertz range. So they're switching signals at gigahertz range. That's why. So don't put a 1N914 in there. Get some 1N3070s. That's why it has those diodes in there.
Hey, speaking of diodes, I had this in the mailbag section, but let me bring it up now, because we got an interesting question from Walter, a guy that we've talked to for a long time, KA4KXX down there in Orlando.
The Sunrise Group.
The Sunrise Group. Walter's a long-time home brewer, QRPer. Really knows. He's one of these people who knows which end of the soldering iron to grab. And he asked an interesting question. The question is still out there. It's about diodes. It's about the diodes that are in the amplifiers in the BitX20. All right. So the BitX20 has these amplifiers. They're bidirectional amplifiers. They're not TIAs yet. But Farhan had diodes going from the supply up through the diode, I think through a resistor to the collector of the transistors, so that when you through the TR switch from T to R, you keyed a relay, that in T sequence powered up some of the transistors, in R powered up the others. Walter's question is really, what does the diode do? And I think it's a good question because in later versions of the bidirectional amplifier, specifically the TIA amps, there are no diodes. You don't see those diodes there. So Walter asked about the diodes. I passed the question on to Farhan, but then Farhan went on the road. So we're waiting for the response and where Farhan's going to explain the purpose of the diodes. But it's got me scratching my head because I think, and I think Walter's right, that you could just dispense with the diode and those amplifiers would work just fine. As a matter of fact, I think he said that VK3YE, Peter Parker, down there in Melbourne, has been doing that, just sort of dispensing with the diodes. So let's think about that. Anyway, it's a kind of an interesting question, and since we were talking diodes, I figured I'd mention it here.
Yeah, I don't have a good answer for you.
I know,
unless it was diode steering, that's one thing.
But it wasn't even really steering. I'm not quite sure. But I remember when I was building my first BitX, I got the idea of using LEDs instead of regular old diodes.
Ooh.
Use red ones for the transmit side, green ones for the receive side. And I remember writing to Farhan, this is way back 2014 or so, writing to Farhan about it. He said, nah, don't do it. You might mess something up. So,
yeah.
I still think it would be kind of cool. Hey, anything happening with your national receiver, the national receiver that you were encouraging me to get one of because of the nifty electromechanical display?
No, it's just here. I had to move it off the bench because I was working on the PSSST. Hey, but I wanted to share a piece of information with you because I copied you on an email that I sent to Jameco.
I saw that,
about soldering irons. Okay, so I noticed with the new transceiver, I was hearing some noise. I was hearing some noise in it, and I'd pull the antenna and the noise would disappear. Plug in the antenna and the noise was there. So I said, God, what the heck's that? So I'm working on it. So then I said, well, geez, I almost burnt myself on the soldering iron. I unplugged the soldering iron and the noise went away.
This is what happened with me with the treadmill. I had the treadmill, and
I said, wait into the soldering iron. So this is a cheapo soldering iron, must have a switcher.
They got switchers in everything. All these little supplies. The wall warts have switchers in them.
So I mean, the soldering iron was plugged into the same power bar as the power supply for the rig. So I mean, it was, and I wouldn't have noticed it if I hadn't unplugged it because I said, well, I'm done with that. And all of a sudden the noise. I said, wait, let's do that again. So I plugged it in. You get the noise.
Yeah. Well, at least that's what the problem is. I mean,
yeah.
But you also talked about a bigger problem with these the temperature stabilized power soldering irons.
Yeah.
And I picked one of these up. I'm pointing to it now. The Xtronic 4000 series. This was recommended by the really great podcast Chat with the Designers from the New Jersey American QRP Club. And I used it for a long time. I really liked it because it has the hot air blower that you could use for the occasional removal of surface mount parts. I would sometimes use it just to shrink the heat shrinking that I put around wires. But it just recently gave up the ghost on me.
Oh.
Another one. I know you got them. Yeah. Now I also have one of these Heiko soldering irons. This one's kind of different because when you put it in the stand, it reduces the temperature of the iron to about 400 degrees Fahrenheit. When you take the iron out of the stand, you have to pause for a few seconds until you hear a beep. When the beep comes, the tip has gone up to 700 degrees Fahrenheit. And this, I think, actually is pretty good. It prevents you from sitting there cooking the iron all the time, because one of the things without temperature stabilization is those tips burned up really fast because they were sitting there for hours and hours at 700 degrees Fahrenheit or higher. So this thing actually is working pretty good, and I like it. So I'm sticking with that one. I don't know how long it's going to last, but you were complaining to Jameco about their lack of longevity.
I said, you're pushing this thing, and they're pushing the Zytronic just like you got. And I said, have you guys used one? Use it for a while and see what if it doesn't die after 6 months. And I said, if you find one that lasts more than 6 months, you're going to sell a ton of them.
Well, Pete, Well, most people don't use soldering irons as intensely as we do.
Yeah.
we should be like the testing ground for soldering irons. If they can make it through Giuliano's workshop, that's a good soldering iron.
Yeah.
They'll run ads like on Card TV. Even in Pete Giuliano's workshop, this soldering iron lasted more than 12 months. Holy cow!
Yeah.
There's an opportunity here, Pete. Opportunities.
Oh, okay, I'm done.
All right. All right. Let me talk about my bench. First, I want to say something else about Farhan. Farhan did a talk to the Radio Society of Great Britain. He had to stay up till 3 o'clock in the morning to be on the same time zone as the Brits at the convention. And man, I really loved his presentation. I was so enthusiastic about it. I said if I was limited to one YouTube video this year, this would be the one that I would pick. And even though Farhan, it was all about VHF. It's about Farhan building a 2-meter sideband version of the BitX transceiver. Now, I am not a VHF guy. You are not a VHF guy. But it was just fascinating to me to see Farhan kind of tackle the problems and the questions that arise with VHF construction. Things like, would an FT 43 toroid work at 2 meters? The answer is yes. Would various transistors that he was working with operate at those frequencies? Yes. We all know you have to keep the leads shorter. The parts have to be closer together. You have to pay more attention to stray inductance and capacitance. But he was able to do that. And in the course of doing that, he explained a lot about construction process applicable in the HF range too. But of course, as I watched him talk about 2 meters, I sat here and thought, hey, 2 meters. Yeah, I want to do that. It's like, you're being lured in. And so I started looking around thinking, what kind of 2-meter gear do I have here? And around the same time, I was reading Chuck WA7ZZE's book about Heath kits. Beautiful book, by the way. Get this book if you can. And so that and Farhan caused me to go into the junk box and pull out, and I have it sitting over there on the bench. Look at it's looking at me right now.
A tour.
Mocking me. It's scorning me. It's mocking
me.
It's a tour. It's a Benton Harbor lunchbox for 2 meters. All right. So I started thinking, all right, I'm going to start out seeing if I could get something to produce a modulated or even unmodulated signal on 2 meters. Now, the Benton Harbor lunchbox it's not really a transceiver. It's more a transmitter receiver. There are actually no common stages other than the power supply. The receiver is a super regenerative receiver. What horrible beasts these things are. He is making a hand sign indicating broad as a barn door.
Yeah, well, it tunes from 136 to 174 in a little space like that.
Not only that, nobody really knows how the thing works. Your picture just disappeared. You there? There you are. You're back.
Yeah.
Anyway, all these kind of explanations, and you could tell they're hand waving explanations. When you read the explanation and you really get the sense that the guy who's writing doesn't really understand it, you can almost see his hands waving like, yeah.
He's Italian.
Now, I did manage to find a couple where the guys really seemed like he knew what he was talking about. But God, it's complicated. It's not even really like a regular old regenerative receiver. It's more like pulse width modulation, and it has, oh God. And then you read this whole thing, you finally understand it, and what you understand is it really doesn't work that well. All right. So I said, okay, I'm not going to mess with the super regenerative receiver because it's super strange. On the transmit side, they got 3 little tubes in there that, goes from like an 8 megahertz crystal and multiplies and multiplies and multiplies. And in the end, you're up at 144 megahertz. So I figured, how hard could this be? I got 8 megahertz crystal. I plugged it in there, tweaked the first coil, tweaked the second coil. Man, I could not get this thing to transmit on 2 meters. Couldn't do it. And then in the process of messing with this stuff, first of all, now I'm going against all my principles because I'm messing with stuff at 200 volts, which is not a good idea for a transistor guy. So almost like in a warning to me, I dragged across. I don't get my hands in there, but when I was removing the leads from an audio oscillator from my beloved Maplin audio waveform generator that I have right here. I dragged the input terminal right across the tube, the energized tube, putting about 200 volts across the input terminal of the Maplin audio waveform generator. Pete, it doesn't like it. It's not good for it. It released all of the magic smoke. Now, okay, so now this is like adding insult to injury. Not only can I not get the tour to operate on 2 meters even in transmit, I've destroyed my beloved Maplin AF signal waveform generator in the process. Now, I managed to fix the Maplin, or Maplin, however you say it, Maplin. Yeah, that's right, Maplin. Anyway, I fixed it by by ordering through eBay and Amazon all of the chips. This is sort of like the shotgun approach. I knew I blew up one of these chips, but I wasn't sure which one. So I just ordered replacements for all of them, replaced all the chips, and sure enough, now the thing works. It's kind of a crude troubleshooting way, but I did it. But anyway, I have now, and then here's the other thing. As I'm doing this, I'm thinking to myself, I might be missing out on all this great, QSO stuff going on up there in 2 meters. There is none. There's nothing up there. I mean, it's like especially, so I'm building for AM. There's barely FM activity up there. Even in Northern Virginia, one of the most intense technological regions of the country. If you go and listen to the 2 meter repeaters, it's mostly just dead air. There's nobody up there. So if I went up, even if I succeeded and got a 2 meter AM station going, it'd be like nobody to talk to. So after a while, I came back to my senses. I stopped working on 2 meters, but I know that Farhan will do something else that will cause me to get back into this kind of VHF madness. Then there's the Frank Jones, VHF guy. I don't know. What do you think?
Part of that, Bill, might be localized in India, where there's a lot of high density population. Not a lot of room to put up antennas, whereas 2 meters and 6 meter antennas are something you can stuff in your yard, not a 40 meter dipole. So I could see the interest in doing it in his country because of the density.
Yeah, and Farhan was also doing it because he uses it a lot for satellite work. So he's deeply involved in the satellites. We'll talk about that again in a minute. But I don't know. I am putting the tour on the shelf, on the shame shelf. I'm putting it on the shame shelf.
well, if you have a real interest in doing that, another option, because I was talking to Steve Hartley about this. Steve has got a group of people building a sideband transceiver. They're in the UK.
Yeah.
And so he's taken some elements of some of the stuff I built, and it's a new design, but he's using some bits and pieces. And he was talking a little bit about, VHF, and I said, think transverter. Take one of you can eBay's got tons of transverters for $20-$30. You can take a 17 meter BDX or a 15 meter BDX or 20 meter BDX and put a transverter on it, and you're in business.
Yeah, I was looking at one of Farhan's designs. I'm not sure which one it was, but one of his more recent designs, and this may be coming out of his GQRP presentation, I think, which has not yet been released to the public.
No.
But those of us in the Illuminati, we've been able to.
Got connections.
I know a guy.
Got connections.
Connections. Anyway, I think in that he points to a design where he deliberately leaves 2 terminals coming out of the rig for connection to a transverter. So yeah. I mean, that thought has crossed my mind too. So anyway, we'll stay tuned. We might find some activity on 2 meters. Hey, but that's looking forward. Looking back, I've been playing with my Mate for the Mighty Midget receiver again. I have it sitting here right next to me. You could see I'm pointing here, but there it is. It is also in the box from a tour. This is a tour that I destroyed. But I did it back in 1998. I built this thing in 1998.
Well, statute of limitations is expired.
It's expired, thank God. Yeah, 3 6U8 tubes using the power supply from the tour, and it's a single sideband CW receiver for 75 and 40 meters. using a 455 kC IF. All right. And I mean, I've been fidgeting with this thing, and the thing that really required the most fidgeting is the filter. All right. Because when Lou McCoy designed this thing back in 1966, his idea was to use surplus crystal filters, FT241s, at 455 kC. This was an iffy proposition even in the days following World War II, because a lot of these 455 kC filters were bad. They were bad from the get-go. They were bad during the war. But if you got two good ones that were properly spaced, you could put it in there, and they kind of, sort of, if you looked at them right, served as a decent SSB filter. If you got them too close in frequency, you got kind of a sort of decent CW filter. But it was all kind of hit and miss. I never could get the thing to work. I used a 455 kC IF can in place of them, which left the receiver broad as a barn door, but I could listen to it. Then I went through all different versions over the years. I put a CM5 Toyo 455 kind of hybrid crystal filter, mechanical filter in there, too high insertion loss. I found a B&W 455 kC filter that promised to be really narrow, put that in there, didn't really work right. I recently started talking to somebody else who's working on one of these, Scott, WA9WFA, and it occurred to me to try a ceramic resonator in there. And you can get ceramic resonators of all different bandwidths. I happen to have one in the junk box that was at 455 kCs with a bandwidth of about 6 kCs, which is too wide for SSB, but just about right for AM. And I like to listen to SSB and AM, so I put it in there. I figured out how to put it in there. Man, it is working better than any of the other versions. It is so nice. I run it with a little computer kind of powered speaker that I have here. And I just use it sort of for easy listening. When I'm working on something else in the shack, I turn the thing on. I tune to 75 or 40, depending on the time of day. And I listen to the chatter, or listen to guys talking. It's AM sounds great on it. Sideband sounds great on it because it's broad. I've got the BFO placed at the very low end of the passband. I measured the passband with the nano VNA, so I know what the passband looks like, and I know that allowed me to figure out where to put the BFO. So I put the BFO way down at 451, which means that the opposite sideband rejection is great. And then everything above 451 is coming in, and so that's where the broadness comes in. But it really doesn't matter. It sounds great, and I've really enjoyed working on this thing. It's a fun tinkering project, and I've had a lot of fun with it. Hey, go ahead.
I just want to interject. When we talked about this in the last podcast, I said find the J version, the Murata J.
I've got to find them, I've looked for them. I know that they're available from a couple different places, and there are kind of narrower versions. You could get it. I've seen them advertised down at like a 4 kC bandwidth, which would be better for SSB. But I'm tempted just to leave well enough alone, because this, with the filter in there that I have now, it works really well on SSB and it works great on AM.
Well, what I was going to share is that they used the J version in the high-end ICOM rigs.
Yeah.
And they want like $95 for one of those. But what I was going to suggest, contact Murata, say you'd like to evaluate. Do they have a sample? I mean, I did that with mini circuits, and they sent me 4.
I'll give it a try.
What's an email? Send them an email. Hey, and by the way, on those FT241s, you have the sideband handbook with the picture of Rudolph Fisher's HRO homebrew receiver.
Yeah.
Okay,
yeah.
Look in there. There's a 75-meter single sideband transceiver that uses 3 of those FT241s for a crystal filter. When I looked at that, I said, "Who are you kidding?" But there's a project in there with 3. They use 3 FT241s.
Yeah, I went back and I was doing some reading on the history of early sideband, and some people have pointed out, I think in Stoner's SSB handbook from like around 1954, 55, he points out that even then, about a quarter of the FT241 crystals that they found at 455 kCs were already bad. I mean, and this is before 4 or 5 decades of sitting in a musty basement, which couldn't have improved things. Hey, just one other thing, since we're on this subject, I spent an inordinate amount of time trying to discover the myth behind, discover the true origins of the SSB convention that has us running LSB below 10 megahertz and USB above. And I came across something the other day. I was looking at the QRP book, QRP Classics from the ARRL, and there's an article in there about band imaging receivers. And this guy was building one for 17 megacycles and 10 megacycles. So the 17 meter, 18 megacycles and 10 megacycles. And so, in other words,
30.
the
30
17
and
meter
17.
band and the 30 meter band. And he was
Yeah.
building a band imaging receiver. And in the article, he starts talking about how in the early days of, well, back in the post-war period, it was popular to build receivers for 75 or transceivers for 75 and 40 using the band imaging technique. But the IF was not at 9 megacycles. It was at 1.7, right? And with the filter with the IF at 1.7, you did get the effect of 75 is on LSB and the other one is on USB. All right. So that was kind of interesting. And I saw that and I said, wow, that's something right there. So maybe I'm just thinking about it here. 3.5, maybe 0.5. Yeah. Then you'd have to run the VFO higher to get it down to 1.7. Yeah. So it would work there, but it definitely did not work with the 9 megahertz filter and the 5 megahertz VFO of the command set. So anyway, more to follow on that. I'll put something up on the blog about it. Hey, listen, a couple other things. I'll go through this kind of quickly. A few other things on the bench. Sweeping an IF, sweeping a crystal filter with noise. This is something that Tony Fishpool recommended a long time ago, and I was wanting to do it. Now I have the tiny SA, the little tiny SA here, in the exact same box as the Nano VNA, the tiny SA. And basically the idea is you take a noise generator, a broadband noise generator, put it at the input of a filter, put the tiny SA on the other end and see what frequencies make it through the filter. This gives you an idea of the passband. And I did it and it worked, but I used the filter that Dean and his crew used with their simple SSB transceiver that you designed. And the thing is, the filter, I know it has a nice looking passband, but it didn't look nice when I did it. It worked, but there was like a kind of a bumpy passband in there. So I started thinking about that, and I realized that my noise generator was not producing kind of noise at the same level across the band of frequencies that we were interested in. I was using my little Fieldtech SIG generator, and the noise that it was producing was bumpy. So bumpy noise in, bumpy passband out. So I need a better noise generator, but the concept works, and it was a lot of fun. One other thing about the Tiny SA, ooh, this is fun. There's a mod to the Tiny SA spectrum analyzer that allows you to use it as a receiver. All right. So you go in there and you solder in a couple connections and you put like a little speaker or earphone jack on it, right? And then when you're tuning across, for example, the FM broadcast band, and you put the cursor on 100.3 classic rock in Northern Virginia, you stick the headphone in and you can listen to it. Now, this is a really cool mod of the Tiny SA. You don't get to do too many hardware mods of the Tiny SA. Here's one. I have it up on the blog. Check it out. It's really pretty cool. I didn't invent it. I'm just putting the link up there. It's really kind of cool. Hey, one final question I have here, Pete, and I've already posed this question to you. I'm going to throw it out to the group. I had such fun building the 7520 Mythbuster transceiver. It's essentially a band imaging transceiver, right? That allows one VFO to be used, add one and then subtract on the other side, add one side, subtract on the other side, and you get 75 and 20 meters. In this case, because you're doing it that way, you get USB on 75 LSB, LSB on 75, USB on 20. Now, I would like to do the same thing. Sunspots are coming back. They are. Cycle 25 is doing good, and I want to move higher in frequency. So my idea, and this is why I needed the new Pine board, is to build a similar transceiver for 2 bands, but higher in frequency, not VHF higher, HF higher. And the 2 bands that I would like to get are 17 meters, because I love that band, and 12 meters, because I've never really operated there. So I've been noodling. I've been doing what you recommend. I'm noodling and trying to figure out, is there a way to do this that would work? Now, I know selection of intermediate frequencies is a hazardous business, because if you get it wrong, ooh, trouble. Now, my idea was, wouldn't it be great if I just were able to do the band imaging technique, between 18 megahertz and 29, or was it 25 megahertz? 24.9 megahertz. And so if you split it, the difference, if you had an IF at 21.4 megahertz, right? Now, you can get crystals at that frequency, pretty close.
Didn't Steve build a filter at 21.4?
Steve who?
N8MN.
And did he? I got to check with him. He might have the answer.
Yes, he did.
All right.
That was his latest build, the 21.4.
For what bands was he building for?
17 meters.
Oh, man, I got to talk to Steve. All right.
Yeah.
And then, because this would be really cool, because then I could run one of my beloved analog VFOs. He made a noise. At 3.41 megahertz, right? 3.4, 3.5, and I could get both the 17 meter band and the 12 meter band in there, right? Now, I talked to Farhan about it. Farhan thought that there might be an image problem, because the IF would be too close to the operating frequency, and I'd have trouble because some of the images would get through. So I'd have to be on transmit with the low pass filter. There you are. You're back. We disappeared, but we're back. Anyway, let me know what you think, guys. Now, I found, in one of the GE ham notes that I sent out a while back, a really cool article about how to predict successful IFs, right? But that was in the pre-work band days. So that their predictions, the techniques that they outlined were pretty much for the standard ham bands, pre-work bands.
The 5 bands. Yeah.
Yeah. I wish there was a website, a calculator, where you could plug in an operating frequency, an IF, VFO frequency, and then it would tell you whether this would work or whether you would have unacceptable spurs coming out. I haven't been able to find that yet. If anybody knows of one, please let me know. And oh yeah, finally, I mentioned one other thing. So please send any thoughts about that particular combination or other combinations that might work for a 17 meter, 12 meter dual band imaging transceiver.
But suddenly that brings a thought. The 2-band Moxon, 17
I know,
and 12.
this is another reason that works. There are designs for that.
Yes.
Yeah, yes. I mean,
Yes.
the radio gods have spoken.
Yes.
Yes.
There you go.
We got to do this. All right. One final thing is, I dragged out recently, and as part of this project, I was thinking about a VXO version of this, which is still a possibility. But I dragged out, and you can see it over there. That is my original first ever SSB transmitter, not a transceiver, a transmitter. I built this when I was out in the Azores between 2000 and 2003. And it's got in it a crystal filter out of the Swan 240, which is just 3 crystals around 5.173 megahertz. And it's 2 half-lattice filters. So basically the same thing that Lou McCoy was recommending, 2 crystals in that range, but they used 2 pairs of them. And man, I did a scan of that using the Nano VNA just to see what the passband looked like. Ugly. Whoa, man, that passband was anything but flat. It had a big valley in the middle of it, but back then they didn't care. Oh, you don't have Nano VNAs, you don't know about it. What you don't know can't bother you, right?
Yeah.
But now I know. But then, one interesting thing, I took a look at the manual for the Swan 240. They've got a picture in there, a diagram showing the filter passband, and it's just that. Bloop, bloop, bloop. Today we would consider that unacceptably unflat. So anyway, I just took a look at that. Fun stuff, nostalgia. Anyway, good stuff. Hey, Pete, I know you got to get on the road here soon. You got to get going. So we got to do SolderSmoke Mailbag. You got time?
Yeah.
All right.
I got
All right.
I got a couple of minutes.
All right, we'll do it real quick. If you have to cut out, I'll carry on, do the mailbag.
Okay.
But listen, roots of mailbag, the roots of the mailbag. This is another thing provoked by Steve Aching Sinus Smith. Where did mailbag come from? I started thinking about this, and I think that I was influenced by those shortwave broadcast stations that had mailbags. And I started Googling around. I talked to Thomas, K4W SWL of the SWL Post, and we came up with ideas. Radio Moscow had a mailbag segment.
Yeah.
So did Radio Havana, Cuba. So did HCJB. HCJB had this thing called DX Party
and
Line.
Nice QSL cards.
Beautiful QSL. Those were fake. Anyway, I took a listen. Radio Moscow, I don't think that was really the influence because most of their stuff was really kind of political, Soviet political. Havana, Cuba, maybe. Arnie Coro always had a lot more technical stuff in there. I think the real influence came from the mailbag segment at HCJB, and I have a sample of it on the web page for this podcast. You guys can listen to it from about 1976. I joked with Thomas of the Shortwave Listening Post. I said, I think it's kind of disturbing that I thought some of our early influence might have been come from Radio Moscow. I said, but I guess it could have been worse. It could have been, Brothers Stairs, mailbag.
Yeah, there you go.
He came back and said, yeah, that would be called Stair Bag. All right. One thing I put out, took a look at my novice log, and I took all of the 150 or 200 calls of stations I worked as a novice, put it up on the blog, and said, are any of you guys out there who remember this contact? Look through your logs. I got 3 responses, and it's really great. I heard from the former WN2RTH, who was my second contact, and I worked him frequently. He wrote to me, John. Also, WN2FLK was XW, and also the former WB2RKK. So 3 people have come back and said, yeah, I remember, or you're in my log as a novice too. I recognize it. So that was kind of cool. A nostalgia trip. Dean, N7DA, worked West, W7ZOI in the sweepstakes this year. Congratulations. That's like icing on the cake there. Peter, VK2EMU down there in Australia, talks about the movie Frequency and the magic of heath kits. The heath kits appear in that movie, but they allow the protagonist to communicate with her deceased dad. That's a really good heath kit. It's a little too magical for me. Hey, another blast from the past. We heard from Thomas, KK6AHT. This is the guy with the Minima. He was visiting Virginia, and I posted a blog post. 2 guys in a Minima walk into a bar in Roslyn, Virginia. And he is, I don't know if he's back in ham radio, but he sent me an email kind of updating me on some recent ham radio developments. And he noted that he now has a young son. So fine, that's great. That's wonderful news there, Thomas. We hope you get back into the building game. Chuck, WA7ZZE, we saw, he was the one who asked me whether he has to call me sir. He also sympathizes with my tour trouble. Yeah. And and he also commented, well, Pete's pulling on his black necktie here. Let's see who else we have here. Tim M0CZP. I got a kick out of this one because he was a victim of the spell corrector in his cell phone, and he was trying to say Varactor diodes and instead transmitted Vatican diodes. I wrote back to him. I said, listen, I think you should always use Vatican diodes.
Holy diodes.
They're infallible. They're infallible. Ramakrishnan, VU3RDD, wrote in from India. He's working on a NorCal transceiver and also a noise cancellation arrangement. It's kind of a phasing arrangement. We wish him a lot of luck in that. There's a lot of need for that. Skip NC90. Man, Pete, I felt bad for this because I kind of reacted harshly. Skip wrote to me and he started out by saying that he had heard me calling a French station, but I was 40 hertz off. The audacity. I thought 40 hertz.
He started off by saying 40 kilohertz off.
No, but he meant 40 hertz. But that was, I immediately thought of you. I said, Pete would be biting his finger, emitting Italian curses at this point. Like Sonny in The Godfather or something, you know? But then I realized that Skip had a reason for knowing that I was 40 hertz off because he's a podcast listener. So he knows what my voice sounds like, right? So he wasn't doing this just to be a smart aleck with a waterfall. No, he was doing it based on his knowledge of what my actual voice sounds like. This reminded me of a story from the early days of sideband. You know, they used to organize these sideband dinners. People would get together, and when they heard the other fella talk, they would often remark, "Hey, wow, I didn't know what you sounded like. I had you tuned 100 hertz off," which is a point that I make. You know, if you don't know what the other guy's voice sounds like, you can't tell by ear whether you're, I think 100 hertz is about the limit. When I tune 100 hertz off, it still sounds human. You go a little bit beyond 100 hertz off, it starts sounding like Donald Duck, you know? But within 100 hertz, you just don't know really what the other guy sounds like, whether he has a higher pitched voice or a lower pitched voice. But I'm sorry, Skip, you knew, and he had a reason to know. So I'm sorry if I was kind of harsh there. But 40 hertz, man. I thought of Pete, and I just said, gosh, you know.
The other day, this is funny you should mention that. The guy up in Alaska is on the air, and someone says, OM, I need to check what frequency are you transmitting on? And so he comes back, he said, he says, I'm on 14.198280. The guy says, I knew it. You were not on frequency.
This is on 20 meters?
Yeah.
Oh my God, this is going to be expected on 40. I didn't realize that this has infected 20 meters.
I mean, the guy absolutely knew what frequency he was on. So what do you mean
he's
he's
wrong? But you know, the Europeans don't follow this 1 kilohertz craziness. You know, they don't. Yeah, all right, they're all wrong. Steve K9NVD is a listener, and he's been going back through the old podcasts, and he found an old one way back when I said that I was using Peter Frampton's song on a local FM station to detect RFI. Bob, KY3R, also bitten by the novice nostalgia bug, and he's got rigs similar to the ones that I have, and he wants to know whether he should continue to use a 75-watt bulb as his dummy load. I said,
okay, on vacuum tubes, but solid state, that might be a problem.
Well, I think he's tube stuff. I think it's DX60-ish. Yeah.
Okay. So you're okay with vacuum tubes. Don't do it with solid state. You'll smoke them.
Todd, K7TFC out there in Portland, a great correspondent of ours. He sent me this video about why solder smoke always blows into your face. Why, when you're soldering something up, the smoke comes in your face. I've actually done investigations into this, and they've come up with a very plausible theory about why it happens. I have the link up on the blog. Anthony, VU3JVX, also writes in from India. He has built a homebrew Arduino. Pretty cool. And I have asked for help from Anthony, and I'm going to put a little pressure on him here, or to the whole Arduino community. My only problem with the Arduino is it doesn't go down to 455 kcs. It stops at about 1 megahertz. But I need it to go down below 455, down to around 450 or so I can sweep some of these 455 kc filters I have. So I know this is a matter of just modifying the software and then helping me get it into my Arduino box. Please help me. I need help. Okay, Jack, NG2E, is building Pete's DCRX. Jack is a neighbor of mine here. Great guy, and he's a mountain topper, a soda guy. So Pete's DCRX might find its way on the top of one of the Shenandoah Hills here soon. I mentioned Scott, WA9WFA. He has been struggling with the Mate for the Mighty Midget receiver, and he and I have been comparing notes on it. But he wanted to send me some videos about another receiver that he built, the first receiver that he built, an HBR13. This was a beautiful receiver.
James Lamb.
A lot of work, man. That's a 13 tubes in there. He used 12 because he used a solid state supply. But what a beautiful piece of work. He has a front panel in plexiglass.
Plastic. Oh, you can see the work.
You can see the parts inside. Yeah, I mean, inspirational stuff. I put 3 of his videos up on the blog. Check it out. But congratulations to Scott on making that HBR13 work. Then Steve, 2E0FXZ, he followed the same advice that you gave me, Pete. You told me about where I could get a couple of Yaesu FT101 VFOs. somebody else got one too from the same source, and that's Stephen 2E0FXZ, and he was just asking for some information on the output frequencies for this thing. So I gave it to him. Really, really good. Good luck with that, Stephen. Good piece of gear. Bob, K7 Zulu Bravo has been on the air with a 56 milliwatt homebrew rig and a big antenna out down there in the Southwest. Made a contact. Congratulations. Fine business. Our friend Dean, AC9JQ, has retired and now has more time to devote to radio. So welcome to the club, Dean. And the hours are much better, believe me. Alan, WA9IRS, sent us an update on the right to repair movement and what's going on with the right to repair movement. Apparently the French are coming up with some sort of repairability index for all new pieces of consumer electronics. This reminded me, Peter, something you said about how some of this stuff didn't seem to be designed for service. If they put capacitors that needed to be changed way down deep inside. Anyway, continuing the good fight. Farhan, Pete, as you know, has invited the both of us to speak to his local radio club, the Lamarcan Club. It'll be on December 11th or 12th. I think we might be on at different times, which is fine. And here's the cool part. We're going to be simulcast on television.
Ooh.
None of this kind of YouTube stuff like we're doing now. Like real TV.
Real
time, live. Ooh. It's going through a satellite.
I'll have to wear my bow tie.
Yeah. The OQ or the QO100. This is the geostationary satellite that the Qataris put up that we can't see because it's over the Eastern Hemisphere, not the Western Hemisphere. This is the one where they're putting us to shame by doing something that we haven't been able to do. But Farhan has been working with the people in charge of this thing, and they're going to carry our presentations. So for those of you in the Eastern Hemisphere, tune to QO100, the only amateur radio geostationary satellite. And for those of us in the rest of the world, you can get it online. You'll be able to watch live as Pete presents and as I present, December 11th or 12th of this year. Stay tuned. Should be fun.
But by the way, I get to do what he does. It'll be at midnight.
Oh, man. You got to do it at midnight?
Yeah, midnight.
Oh, God. I don't know what my time slot is. I got to find out. Farhan, have mercy. All right. Finally, I got many suggestions about what to do with my Apollo 11 time capsule. When I was a 10-year-old kid, I collected all the newspapers from the Apollo 11 landing and put them in plastic bags and stuck them up in the attic of my parents' house. The time capsule has come back to me. I really don't know what to do with it. I'm afraid to open it because the paper in there hasn't been exposed to the air in, 50 or 60 years. I'm looking for ideas. A lot of guys sent me the idea saying, stick it up in your attic and let your kids figure out what to do with it. I don't know. I'm looking for something else. So if you can think of something else, let me know. If you can
maybe there's an Apollo 11 group.
Maybe there is. I don't know. Somebody tell me
what
to do with this thing. What to do. Hey, Pete, you got to go. You got duties and responsibilities. So maybe let's close by just saying Happy Thanksgiving to everybody who celebrates this holiday. It's a lot of fun. You're going to be busy. Pasta Pete, you must be busy coming up.
I am. As soon as we finish, I got to go grocery shopping to get in ahead of everybody else so the shelves are not empty.
Wear your beret.
My beret.
And the bow tie. Hey, Pete, good luck. Thanks very much. 7-3 from Northern Virginia.
7-3s from the left coast.
Ciao.